So we're going to go back to math here. I'm thinking of a 10-digit integer whose digits are all distinct.
Pi. I'm kidding.
It happens that the numbers formed by the first n of them is divisible by n for each n from 1 to 10.
Okay.
What is my number?
I don't know, but this pie is delicious.
I know. I got so distracted with that. I was like, oh, I got to answer a question. What am I doing? Let me see if I can find that one on here because I want the wording. What's it called?
This one is called Pi Day.
It's called Pi Day. I didn't. Pi Day
I've
fun?
got it up here too if you want to talk.
Do you have it?
Talk through it, yeah.
Oh, here it is. I found it.
All right.
Whose digits are all distinct?
Correct.
All right. Man, I am slow on the draw today. It's this pie. It's the pie's fault. All right, I've got it up on my screen, copied and pasted from email. Okay, it happens that the number formed by the first n of them is divisible by n. Do you want to talk me through this, Nathan? Do you want to help me do this one?
I think this might be pretty complicated. We can kind of talk through, we might not get the solution to this, but we can talk through kind of like the process and what this problem means. So what comes to mind for me first is divisibility rules for all of these. You know, like if you want to know how many, or if a number is divisible by 3, you add the numbers together. If that's divisible by 3, then it
Right.
works.
But it's a 10-digit integer whose digits are all distinct.
Right, so that means 0 through 10, or sorry, 0 through 9.
Right.
And you
Only
can't
used
repeat
once.
any of the numbers.
Right.
So when we say the number formed by the first n of them is divisible by n, so we're saying like the first 3 numbers
Is divisible
should
by
be
are
divisible
divisible
by
by
3.
3. Oh my goodness.
The first 1 number should be divisible by 8. And the first 2 numbers should be divisible by 2. So we can actually kind of break this down. I think we might be able to figure this out.
Okay.
Break it down and think like,
I think you're right.
yeah, the first number has to be divisible by 1. Well, that's any number.
Any number. So the
maybe
first number, let's do this.
A good idea would be make a
2.
table, right? Or yeah, like what you're doing with the slots.
Okay.
So again, like kind of what we're talking about is this really is going to come down to knowing divisibility rules and trying to think that through.
So
the first one could be any number. Second one's any even number.
Right.
The third
This is like
one,
Sudoku.
yeah, it's a fun problem.
Okay.
The third number would have to be, what options do we have? We have
All 3 of these have to add up.
Right. So, yeah, all 3 of those have to be divisible. So they all have to add up to something divisible by 3. So you'd have to add up to 3, 6, or 9.
Sum of 3. This sounds like it would be a whole lot easier if it were a multiple choice question.
It would, because you could just test them out, right?
Okay.
For the 4, when we have a long digit,
It's these 2 numbers will have to be divisible by 4.
and the way to look at that is divisible by 2 twice. That's just an easier way to, like 50, if you divide by 2 is 25. That's not divisible by 2 again, so it's not divisible by 4.
Okay.
Then we got 5.
So this has to be either 5 or 0.
Right, so that's how we can start eliminating some of them, right?
Okay.
And then for 6, has to be divisible by 2 and 3.
Okay. So that means that this sum of all of these, of all of those numbers, has to be
Divisible
divisible
by 2
by,
and 3.
right.
Right.
Okay. I'm just going to say divisible by 6.
Yeah, and
'Cause
that's
that just-
easier, right?
That one's going to be rough.
7, there is no shortcut, so
Nope.
we'll just
Meh.
not think about that one for now.
Yep. Don't
8,
know.
the last 3 digits have to be divisible by 2 3 times.
Oh my goodness.
And you're right, it is like Sudoku. I think once we get a couple of them, we'll be able to like really narrow it down, right?
Yeah. Maybe.
9,
Okay.
all those digits added together have to add up to 9.
Whoop. Sum of 9. Of divisible by 9.
Yeah. And 10's easy, right? So we already know what the last number is for sure.
0.
0.
Well, yeah.
It has to be, right?
Yeah, has
Which
to be.
means
Which means this
the
one
0,
has to be 5.
has to be 5.
Okay.
All right, and then you figure out the rest. while I work on
Okay. This is a doozy of a problem. Okay, so we already eliminated, if I go back to here, already eliminated 0. Oh, so now that has to be 2, 4, 6, 8.
So we know the second number has to be even. We know the second to last number has to be even.
I'm gonna just eat some pie here.
Yeah.
I don't know.
Honestly, this would take a lot of playing around with, and it really comes down to just testing out some numbers, like being able to eliminate, like Becca mentioned, like Sudoku, and saying like the last number has to be 0 in order for that all to be divisible by 10. The middle number has to be 5, right? That one that we pointed out.
Yeah. Oh, I wrote that in, didn't I?
Yeah.
This is 5.
So that's 5, and we could say what number, the two numbers before it, have to be divisible by 2 twice. So we know that has to be an even number, and so some of the numbers could be like 64 would be an option, 32 would be an option.
There are so many options, though.
Right. So again, this we could probably spend like 10 minutes on this, but
I'm sorry if your teacher assigned this homework problem
Yeah.
because it's not easy.
think about the divisibility rules and just play around with it. You'll start to be able to eliminate some of the options.
Very true. And this is probably one that you would play with. This is not something you can write an equation for.
Right.
Not at all.
Yeah.
It is a lot like Sudoku. So
Yeah.
I don't know. We'll play around with it more, see if we can come up with an answer by the end of the show. But who knows?
Yeah.
But at least we gave you an idea of what the question means.
Yeah. A way to start.
Yeah.
Yeah.
So hopefully we were kind of helpful.